Hello everyone, and welcome back to our channel. In today's tutorial, we're diving into one of the most classic programs to learn about Hadoop, the WordCount program. This foundational example will help you understand how to process large datasets in a distributed fashion. So, let's get started. First, let's talk about what Hadoop is. Hadoop is an open-source framework that allows for the distributed processing of large datasets across clusters of computers. It involves two main components, HDFS, which stands for Hadoop Distributed File System, and MapReduce, which is the processing engine. To run Hadoop, you'll need to have it installed on your system. You can find detailed instructions on the official documentation page. For this tutorial, I assume you have Hadoop set up and running smoothly on your machine. The WordCount program's main aim is to take a text file as input and count the number of occurrences of each word found in that file. Let's dive into the code now. Let's start with the necessary imports. You'll need to import a few specific Hadoop libraries to handle MapReduce tasks. Here's how your class should begin. Next, let's define our mapper class. This is where the actual mapping will occur. We'll create a mapper that takes in the input key and value, and will output a key-value pair representing the word and its count, which in this case starts at 1. Let's take a closer look at this mapper. We import the necessary libraries, define the mapper class, and override the map method. In this method, we tokenize the input line into words. Each word is then emitted with a count of 1. Now that we have our mapper set up, let's proceed to define our reducer. The reducer will take the output from the mapper, aggregate the counts, and provide the final count of each word encountered. In the reducer class, we again import the necessary libraries. This class maintains each unique word as the key and a list of counts as values. The reduce method aggregates these counts and outputs the total count for each word. Now that we've got the mapper and reducer defined, let's move on to the main method of our WordCount program. This is where the configuration of the job happens, and we specify the input and output paths. Here in the main method, we initialize the Hadoop configuration and create a job instance. We set the classes for the mapper and reducer we defined earlier, and also specify the input and output formats. Finally, we check if the job completed successfully. Now, let's take a moment to discuss how to package this program into a JR file so that it can be executed on a Hadoop cluster. You can do this by using the following command in your terminal. Make sure to replace /path /compiled/classes with the actual path where your compiled.class files are located. This command creates a JR file containing your WordCount class along with the necessary dependencies. Next, ensure that Hadoop is up and running by starting the Hadoop services. Depending on your Hadoop setup, you could use commands like these. With the Hadoop services running, you can now copy your input files into HDFS. Here's how you can do it. Make sure to specify the actual paths for both local and HDFS locations. This command copies your local input file up to your Hadoop cluster's file system. Now, let's go ahead and run the WordCount program using the following command. This command specifies the JR file, the main class name, the input path in HDFS, and the output path where results will be stored. Make sure your output path does not already exist, as Hadoop will throw an error. Once the job has completed, you can check the results by listing the output directory like this. If your job was successful, you should see a part file containing your word counts. You can view the output using this command. This will display the count of each word present in your input text file. Before wrapping up, let's summarize what we've learned in this tutorial. We started with an overview of Hadoop, then we structured our word count program by implementing the mapper, reducer, and main job configuration. Finally, we packaged the application and executed it on a Hadoop cluster to see the results. If you found this tutorial helpful, please consider giving it a thumbs up and subscribing to our channel for more content like this. Feel free to leave comments or questions below. I'd love to help you out. Thanks for watching, and happy coding!